Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 4, I guess, for this week. And sort of already did a bonus earlier today when I did the post-mortem on the Lacama tornado, and just absolutely tragic that that one gentleman lost his life as a result of that. This is really an opportunity for me to really try to drive home a point here, is that when these things happen in the middle of the night, it obviously is going to cause a lot more problems during the day because you don't have your TV on, you don't have your radio on, you're not near your computer, you're asleep. And this is why these NOAA weather radios are so valuable, because you can program them for your specific location, or at least county anyways, and have an alarm go off if a warning is ever issued for your neck of the woods. And it's an obnoxious alarm, and so there's no way you're going to sleep through it. And the National Weather Service is on duty 24 hours a day, and they're issuing those warnings as soon as they see those signatures on radar, or they get a report from somebody. And so I suspect, I don't know this for a fact, but I suspect that this gentleman probably did not have any way of knowing what was coming at him, and as a result, he lost his life. So it's really a good idea to, and they're not terribly expensive, but it's a really, really good investment to make sure that you're not caught off guard in the middle of the night, because, you lose your property, you can replace that. Use your life, can't do that. All right, so let's take a look here at some concepts about moisture that I thought you might find interesting. So this is a chart showing, and let me back up here a little bit. There's something in the atmosphere called vapor pressure, okay? And it's a part of the overall atmospheric pressure, okay? You have the air, the nitrogen, the oxygen, and so forth, but then you also have water vapor, and that exerts a relatively small, but still part of the overall pressure of the atmosphere. So those numbers going up along the y-axis here are vapor pressures. Don't worry about the values. It just means that as those numbers get higher, there's more water vapor in the air, okay? And so this is what we call the saturation vapor pressure, which means that this is the maximum amount of vapor that could exist at a given air temperature, okay? So down here at 40 below zero, okay, the vapor pressure is only 0.18, okay, very, very small. And you increase the temperature 20 degrees and it goes up 311%, okay? So, but there's so little water vapor in the air at those kind of temperatures that it's easy to increase it by 311%. That makes it look more impressive than it really is. Okay, now we go from minus 20 to 0, and we have a 270% increase. Okay, so not quite as big as that first one, but still up there. Then we go from 0 to 20, and we have a 246% increase. 20 to 40, a 226% increase. 40 to 60, 211, and 60 to 80, a 198% increase. And so you notice that the last few of those were right around 200%, and this is why we talk that at reasonable temperatures that we experience during most of the year, that for every 20-degree increase in the dew point, you have double the amount of water vapor in the air, okay? So again, 40 to 60, 60 to 80, 20 to 40, it's roughly doubling in all three of those situations. So, it makes a big difference. Just a 20-degree increase in the dew point can make a big difference in how much water vapor is in the air. Okay, now let's take a look at a situation where we have the exact same amount of moisture in the air. And we're going to say the dew point is 75, which is sort of where we've been of late, pretty humid. And so the dew point is 75, and that's not going to change, okay? But what we are going to change is the temperature. We're going to start off at 75, and when the temperature and the dew point are equal, the humidity is 100%, the air is saturated. But we're going to increase the temperature from 75 to 95 along the y-axis, and the relative humidity is almost cut in half. It's down to about 52%. Amount of water vapor hasn't changed, okay? But the temperature's gone up 20, and so the capacity to hold water vapor has almost doubled, and so as a result, the relative humidity is dropped to 52, 53%. And this is why relative humidity is useless in terms of telling you how uncomfortable it is outside, because your body is reacting to the absolute amount of water vapor in the air. It doesn't care what the relative humidity is, okay, how much water vapor there is compared to how much there could be. So you could have a temperature of 100 and a dew point of 70, and the relative humidity would be 38%. And you're thinking, oh, that's not bad. But your body's saying, hey, the dew point's 70. That's a lot of water vapor. The moisture on your skin is not going to evaporate as efficiently because there's that much water vapor in the air. And so you're still going to feel miserable, okay? So that's why we really drive home the dew point as being the key indicator on how uncomfortable you're going to feel when it starts to get humid. The temperature really doesn't have a whole lot to do with it. In fact, as the temperature and the dew point go up, the heat index goes up, okay? And so your relative humidity may be what you think is reasonable, but the absolute humidity is high and the temperature is high, and the result is you feel terrible when you go outside, okay? So relative humidity, don't worry about it, and at least with regard to comfort, okay? It just doesn't play a role, but the absolute humidity as measured by the dew point really has a big effect. All right, that is bonus weather video number 4 for this week. We'll have another one finishing up the week tomorrow, and of course the next daily weather update coming up tomorrow as well. So you all have a great Thursday evening, and we will talk to you again shortly. Take care.